Lesson 6.5 is where we are picking back up today, continuing in the second half of the chapter, and we are solving square root and other radical equations. So you have done bits and pieces of this. Some of it will be new to you. Some of it will be not new. Just depends. So first thing though, before we get too far, there's a note up there. An important thing to remember solving equations when you have to power both sides. We'll talk about what that means in a moment. But you have to check for extraneous solutions. Do you guys remember what it means, what extraneous solutions are? What? Yeah, extra solutions. They're legitimate solutions that you came up with from solving a problem. They're legitimate, but when you go back and check them, they don't work. Okay? So, extraneous solutions. I'll talk on and off throughout the homework today about checking your solutions. It'll be towards the end, probably what we do tomorrow, where we'll really get into the idea of extraneous solutions. So, just kind of a key note to remember there, anytime you're dealing with the radicals and the powers, that we have to watch out for extraneous solutions. Now, as we look at example A, or 1A, these are equations that you could have seen in Algebra 1. A is 3 plus the square root of 2x minus 3 equals 8. Any thoughts or ideas on how to solve this? Ashley?
You subtract the 3 over.
And what's my goal in subtracting the 3 over?
You subtract the sides, right?
Right. But what's
and
the...
You're also trying to single out the square root.
Okay. So single out the square root. What I'm going to say is isolate the square root or the radical. Yeah. Okay. Your number one job is to get that radical by itself. So we want the radical on one side, everything else on the other side. In this case, as we look at the radical, it's 3 plus the radical. So how do I move this 3 that's being added? It's a positive 3, so we're going to subtract it. If you subtract 3 from the left, subtract 3 from the right. So now, 3 minus 3 cancels. I have the square root of 2x minus 3 equals 8 minus 3, which is 5. So, number one job, and I'm even going to write it in the middle here. Isolate the radical. Always your number one job. Now that I have isolated the radical, thoughts on what to do next? In other words, how do I get that radical to disappear?
You square both sides.
Yeah. If it's a square root, we want to raise it to the power of 2. So if we square the left side of the equation, square to the right. What is the square root of 2x minus 3 squared? 2x minus 3. What is 5 squared? 25.
I feel like I remember doing this.
You've definitely done it before.
Yeah,
this is not new.
I feel like I remember.
And this does go back to the idea of what is the square root of smiley face times the square root of smiley face?
Smiley face.
That's smiley face, right? Well, it's the idea, square root of smiley face times square root of smiley face is square root of smiley face squared. So square root of smiley face squared is just smiley face, right? Since you guys we keep talking about it. Now, from here, I don't know, 6th, 7th grade equation to solve. If it's 2x minus 3 equals 25, we add 3. So then we have 2x equals 28. And then my job is to divide by 2, and so x is 14.
Wow. I thought you said 20. I was like, where did 20 come from? I said 14 and then everyone else said 28. So I was like,
So is the
don't divide it by 2 and not 28.
or is it just this part?
Just this lesson. Okay, now, not a huge deal here, but I want to start talking about it. How do I check my solution?
Plug it in.
Plug it into the original, yes? So 14 into x in the original. So if we just do a mental check here. 2 times 14 is 28. Minus 3, 25. Square root? 5. And then 3 plus 5 is 8. So does it check?
Yes.
It does.
We're so good.
Okay.
So this is like basically just
It's all equations today, yes.
I like
Wait, today it's what is it tomorrow?
This lesson is all equations.
She says this lesson is on
Okay, B. Square root of 4x plus 1 minus 5 equals 0.
Add 5 over equal sign.
Okay. It's minus 5. We want to add 5. And we're adding 5 so we can get the radical by itself, isolated. So square root of 4x plus 1 equals 5.
Bless you.
Okay, how do I get rid of that square root? You square it. If I square the left, square the right. What happens when we square the square root of 4x plus 1? 4x plus 1. 5 squared? 25. If it's 4x plus 1, subtract 1. 4x equals 24. If it's 4 times x, divide by 4 and
6.
x is 6. Can we check this problem?
Yes.
Put the 6 in. 4 times 6? 24 plus 1? 25. Square root? 5. 5 minus 5?
0.
0. So it checks again, yes? Okay. Are we okay with these?
Yes.
Again, that should be old news. To me, that's Algebra 1 material. You've seen it. It's just a matter of remembering it. Okay. Moving on to example 2 then. Example 2, we're still solving equations. And I'm going to tell you guys, every equation we solve today has a radical in it. Now, do you physically see the radical in this next example A?
No.
Okay, yeah. What represents the radical in this equation? It's the fact that it is the parentheses raised to the 2/3. Because remember, okay, let's review. Parentheses raised to the 2/3 is what kind of radical?
Cube root.
It's a cube root raised to the second. Does that sound familiar to last lesson?
Yes.
Okay. So even though it's the power to the 2/3, that is a radical because it's a fraction power. Now, so same first step. Is my radical isolated? Or in this case, it's not so much radical as the parentheses. Are they isolated? Okay. So to get rid of that 3 that's out front, it's 3 times that parentheses raised to a power. So to move that 3, divide the 3. If you divide by 3 on the left, divide by 3 on the right. On the left, x plus 1 to the 2/3 equals 12 divided by 3. Okay, there's 2 different ways we can go about this. And I'm going to show you both between a couple of different problems here. If you wanted to go the radical route, which I'm not going to, think about it here. How do you get rid of a cube root? If we look up at the previous problems, when it was a square root, what did you have to do? You square it. So how would you get rid of a cube root? You cube it. So you'd have to raise it to a power of 3. Now, we also have this squared here. How do you undo a squared? Not, if it's already a squared, you don't square it, you square root it. Okay? So there's 2 different things that have to happen. And if you're in the radical form, we can do this in 2 steps. And I'll show that in the next example. But here, we have this fraction. When you have that fraction exponent, think reciprocal. What is the reciprocal of 2/3? Just the reciprocal. Don't change the sign. So the reciprocal of 2/3 is 3/2. Let's raise both sides to the power of 3/2. If I raise the left to the power of 3/2, I'm raising the right to the power of 3/2. Now, look at what happens on the left. When you're raising a power to a power, you multiply those powers. What is 2/3 times 3/2? Yeah, 2 times 3 over 3 times 2 is 6/6, which is 1. So what do we have on the left? X plus 1 raised to the first, technically, because 2/3 times 3/2 cancel each other out. So we just have x plus 1. Now, on the right, we have 4 to the 3/2. I would prefer, because I don't want you just grabbing the calculator here like some of you do, put the 4 into the radical and let's process what this means. What does that 3/2 power mean? Are we okay with that?
Yeah.
The denominator of 2 says it's a square root. The power of 3 says at some point you have to cube it, right? Whether you're first or last. Now, there's one more thing we've got to consider here. If, okay, side note. Sorry, lots of side notes today. If I give you the equation x squared equals 25. And? Plus or minus 5, because what happens, what do I always say? When you take the square root of both sides, you have to account for plus or minus. So you have to put a plus or minus on both sides. What did we do here? We took we raised the power of 3/2, but what kind of root were you taking? Square root. So what do I have to throw in front of this? Plus or minus. Now, what I'm going to say, I'm going to put a note here off to the side or kind of in the middle. When do we use that plus or minus? When you're taking like a square root, so when you're taking some kind of even root, or when you look at the fraction, if the denominator is even. So right here it was 3/2. So because that denominator was even, that's why we put a plus or minus. So if the denominator or index is even, use plus or minus. And so that's why you saw me put the plus or minus there. So I'll let you write yourself a note there if you want. And then let's clean up that right side. On the left, I still have x plus 1 equals plus or minus. What's the square root of 4? 2. Raise to the third power?
8.
8. So my equation is x plus 1 equals plus or minus 8. And if you preferred, you could have done 4 to the third. 4 to the third is 64, and the square root of 64 is 8. Doesn't matter which way you do that. How do I finish this up?
You have to subtract 1 from negative 8 and positive 8.
Okay, so how many answers am I going to have? 2. Okay, I'm going to set up as 2 equations. As long as you know you have to subtract that 1 from 8 and negative 8. That's the key. So I'm going to have x plus 1 equals 8, or x plus 1 equals negative 8. Since it's x plus 1, subtract 1. So what are my solutions? 7 or negative 9. Okay. So an option of how you can work that problem when you have a fraction exponent. I'm ready for B when you are. Now, I see a radical. First thing I'm going to ask myself is, how do I get that radical isolated? What do I need to do to get that radical by itself? Okay, yeah, I've got 3 times the radical plus 1 equals 25. So let's start by subtracting 1. Then I have 3 times the radical equals 24. Is my radical by itself?
No.
Okay, it's 3 times the radical, so divide by 3. Now I have the radical, so the 5th root of x plus 1 cubed equals 8. I can teach this 2 different ways at this point. One option, and this is what the book would do here, is they're going to take it back to a fraction exponent. They're going to write this as x plus 1 to the what power? 3 over 5. And then they will use the reciprocal power to work with it. And that is a perfectly fine option. Okay? I'm not against that option at all. In fact, that's why I have it here in my notes. I'm going to show you another option in case you're interested. And that is if you just want to leave this in the radical. How do you get rid of a 5th root? Put it to the 5th power. So what we're going to do, well, we could have done 1 step. We're going to take 2 steps to do, but that's all right. So in order to get rid of a 5th root, you raise it to the 5th power. What you do on the left, you do on the right. So now what happens when you do the 5th root of a 5th power, or raise a 5th root to the 5th power? Okay, so we'll cancel x plus 1 to the 3rd. 8 to the 5th is some big number. I'm not going to even mess with it right now. You can, it's 32,000 something, but I'm just going to leave it as 8 to the 5th. Now, trying to solve for x, right? How do I get rid of that 3rd power? Do the cube root. So now, I'm doing the cube root. If I do the cube root of the left, cube root of the right. Cube root of something raised to the 3rd, just x plus 1. Now, I didn't use the calculator earlier because I don't have to. No, I don't know 8 to the 5th in my head, but remember, you have the option. You can either do the 5th power first or the cube root. What's the cube root of 8? 2. 2 to the 5th? Technically, it'd be right here. 32. But my point is that doable without a calculator, technically? Yes. Exactly. Now, yeah, 8 to the 5th. Did you see me doing that out by hand? No. I would have grabbed the calculator if I had to do that. So, do I need a plus or minus? Okay. We did the cube root. It's an odd root. It's okay to have a negative. So, finish it off. It's x plus 1. Subtract 1. X is 31. And I don't care which method you use. Honestly, if you just want to go with, if they give me an exponent, I'll work with an exponent. If they give me a radical, I'll work with a radical. You can. But also, if there's one method you definitely do better with, feel free to switch over. Like, I could have switched right here to this radical to a 3/5 and then raised to 5/3. This one over here, when it was 2/3, I could have made it the cube root of x plus 1 squared and worked from there. So if you have one way, you're definitely more comfortable using it. Otherwise, both in one step.
That way it's like less for error because then that way you have 2 steps. If you mess up on the first step, then you're 6 steps wrong, and everything else is wrong.
Okay, example C. 2 times x plus 3 to the 2/3 equals 8. What do I have to think first? Yeah. Is my radical, so is my parentheses with fraction exponent isolated? No. What do I need to move? The 2. How do I move the 2? It's 2 times the parentheses, so I'm going to divide 2. If I divide the left by 2, divide the right by 2. X plus 3 to the 2/3 equals 4. This is where I'd say, if you really want to change this to a radical, go for it. It's the cube root of x plus 3 squared. Otherwise, how do I deal with that exponent of 2/3?
I changed it to a radical.
Okay, well, I'm not going to change it to a radical, so.
You raise it to the 3/2.
Okay, raise it to 3/2. So if I raise it to the power of 3/2 on the left, guess what? Raise the right to the power of 3/2. On the left, what happens? Yeah, 2/3 times 3/2. 2 times 3 over 3 times 2, 6/6, which is 1. So x plus 3 to the first. 4 to the 3/2. So I'm going to write it out this way. Again, because I'm trying to encourage you guys not to just automatically plug in on the calculators. If I put 4 under the radical, what is this? It's the square root of 4 to the 3rd. Do I need a plus or minus? Yes, because it's an even root. It's a square root. Or because I raised it to the power of 3/2, and that denominator is even. Okay, x plus 3 equals plus or minus square root of 4? 2. Raised to the 3rd power? 8. X plus 3 equals plus or minus 8. How do I finish it? X plus 3 equals 8. X plus 3 equals negative 8. To solve, I'm going to subtract 3. And x is 5 and negative 11. Using the radical? That's fine. Yep. They're both really good methods. I struggle with what's best. So,
I'm just not the instructions.
that's fine. My guess is Math Excel will have you put a comma between answers anytime there's two answers. And yes, there can be two good answers. Okay. Okay, let's look at D. It's different on D.
There's two radicals.
There's two radicals. Any guesses?
There's an imaginary one. You add one of the radicals over and convert it. 3x to the 4x.
Okay. I cannot combine the 3x and 4x because in order to add or subtract radicals, the radicands have to be the same. They have to have the exact same pieces underneath. Okay. Now, what about moving the one radical to the other side?
Bueno.
Can I do that? Yeah. So if it's 1 square root minus a square root, how do I move a minus square root of 3x? You add square root of 3x. What we do on the left, we do on the right. So then I have the square root of 4x minus 2 equals square root of 3x. Guesses on what to do? Can't take the square root of 4 because it's part of a 4x minus 2. Square that. When you have more than one radical, your job is actually to separate the radicals. Once you separate the radicals, square both sides. The idea is you want at least one radical to be totally by itself, which I have. In this case, both radicals are by themselves. So, we're going to square both sides.
Okay.
So what happens when you square the square root of 4x minus 2? 4x minus 2. Square the square root of 3x? 3x. And now you're back down to like a pre-algebra type equation. How do you want to solve?
Minus subtract 4. You can't add 2.
Oh, I see what you mean. Sure, to add the 2.
That way you don't get a negative number. You all have all plus 4. Then you're actually positive.
We're all going to meet in the end somehow or another. If you're determined your x's have to be positive, then you're going to put them on the left. If you're determined you want x's on the left, that's fine. If you're just going with, oh, there's a 3x by itself here, I'm just going to move 4x to join it, that's fine too. I was actually just going to subtract 4x, which is fine. I'm okay with both ways, guys. So then, negative 2 equals negative x. Multiply or divide by negative 1 or switch the signs. So then, any way you go about it, you end up with x equals positive 2. A wrong way or just a different way?
Well, I combined the 4x and the 3 and it just
She
x
got
minus
stuck
2
next.
under a thing, and then I squared it, and then I squared the other thing.
Why'd
and
you
I got
square it?
2. I
You
don't
just
know.
got incredibly
I
lucky.
got 2. And then she's
You
like,
got incredibly lucky.
Yeah, she's like, I don't do that, so I erased it, and then I did the right way. So I got 2.
Okay. Okay. Let's flip over to the word problem.
I like this chapter.
Okay, example 3. For a meteor crater in Arizona, the formula D equals 2 times the cube root of V over 0.3 relates the diameter of the rim in meters to the volume in cubic meters. What is the volume of meteor crater given that the diameter is 1.2 kilometers? Remember that there are 1,000 meters in 1 kilometer. Oh, this is an easy one. What's so obvious here? What'd they give me? A formula, yes? Highly unlikely they're going to give you a formula and not expect you to use it. Just saying. So I'm going to write down my formula. D equals 2 times the cube root of V over 0.3. Okay. What else can we identify in this problem? Okay. It says, what is the volume? So that means we're going to be looking for V. And it gives us the diameter. The diameter is 1.2 kilometers. Now, specifically did it say about diameter in this problem? This formula, D equals, relates the diameter of the rim in meters. Do you think there's a reason that hint was given in parentheses? Yeah. Okay. If there are 1,000 meters in 1 kilometer, 1.2 kilometers is 1,200 meters, or 1,200 meters. Move the decimal, multiply by 100, however you want to think about it. Yes.
This formula, is it 2/3 square root or whatever?
2 times the cube root.
2 to the cube, okay. Thank you.
Okay, so what are we going to do here? We're going to put 1,200 into our equation. So, 1,200 equals 2 times the cube root of V over 0.3. Okay, guys, use what we've been learning all day. How do we solve? Okay, we want to get the radical by itself. So since it's 2 times the radical, divide the 2. 1,200 divided by 2.
600.
600. The 2's will cancel. I've got the cube root of V over 0.3. What do you think, Ashley?
Cube both sides.
Yeah. How do you get rid of a cube root?
You cube it.
You raise to the power of 3. If you raise one side to the power of 3, raise to the other side. I'm going to leave it at 600 to the third for the moment.
Pardon the interruption, Kathy, for you end of the day announcements.
V over 0.3.
High school office, Savannah Botter, Cyrus Johnson, Cassidy Colbert, Mallory Heron. Tutoring for today has been canceled. Don't forget, this is homecoming week. Dress up day for tomorrow is Area 51 Aliens Day. And Expressing Your Trip fundraiser will be February 1st. That is this Saturday. Eat at Panda anytime on Saturday. Show your flyer, and we receive 20%. A flyer is emailed to each student. Thursday. This Thursday there will be a Babe Ruth call-out meeting during activity period A. Seniors, don't forget to be checking your emails for scholarship opportunities, college coaches, etc. There are lots of scholarships. Make sure and apply. Reminder, track preseason will begin tonight. Meet at 3:15 outside the cafeteria. And athletics tonight, we have 6th grade boys basketball at home against Elwood at 6 o'clock. Good luck to the boys. Thank you. Have a great evening.
Okay, 600 to the third equals V over 0.3, because when you cube that cube root, they cancel. If it's V divided by 0.3, multiply by 0.3.
You know, like.
And then
Not again.
0.3's cancel. And so V is going to be equal to 0.3 times 600 cubed, which I will now use my calculator for. The one time I'm using my calculator.
Comes out pretty quick.
So 0.3 times 600 to the third.
Oh my.
648 with about 5 zeros. Yeah. 648,000,000. So 64,000. No. 64,800,000. What's my label?
Meters.
It's volume.
Oh, meters cubed.
Meters cubed. Okay. You are welcome to start your homework tonight. The only thing,
Much worse than this.
the only thing that we haven't worked on is really truly looking at the extraneous solutions.